Okay, we're going to be subtracting integers. So when you subtract integers, remember, integers are just the positive and negative numbers. No fractions or no decimals, okay? They're like whole numbers. So this is your tip. When you're subtracting an integer, there are no subtraction rules, all right? No one gave us subtraction rules. And so what happened was the mathematicians came up with a way to change the subtraction problem back to addition so that we can follow the addition rules. And so we are going to subtract an integer that is the same as adding its opposite. So add the opposite. You're going to hear me say that over and over and over and over. We're changing it to addition, and then we're going and changing the second number to its opposite. Okay? So when you see minus, or when you see that you're subtracting a negative number, okay, it's the same thing as adding a positive number. Okay, it's the same thing as adding a positive number because you're going to change this to addition and change this to its opposite, which is a positive number. Okay, so let's do some examples. So when I look at this, all right, and we'll do it with counters down here further in the lesson, but I'm taking a positive 3 and I'm trying to take away negative 8. Well, I have positive 3 right here. I don't have 8 negatives that I can take away. So that's where mathematicians came up with, well, we've got to change it to addition because we can't do that. That's very hard to do. On a number line, it's easy to do. With counters, it's easy to do. But how do we work it every single time where we have rules to follow? So what they do is they are adding, okay, leave this first number the same. We're adding the opposite. So you're changing this negative 8 to a positive 8. And now you have 3 plus 8, which is 11. Okay, and we'll show it with the counters in a minute. All right, so let's look at this one. 20 minus 3. Now, guys, I know you know that that's 17, okay? We all know that's 17, but if we were to add the opposite, I'm going to show you how it's true. So we're going to change this to addition, and we're going to change this positive 3 to a negative 3. So now we have 20 plus negative 3. So remember from yesterday that 20, we have a positive and a negative. So we can't combine these and say that that's 23. All right, they're different signs. We can't just combine them. So what we do is we subtract, and we get rid of, as we're subtracting, we're getting rid of those 0 pairs. Okay, so we're getting rid of those 3 0 pairs, those 3 negatives. At the same time, we're getting rid of 3 positives. So 20 minus 3 is 17. And do I have more positive counters or do I have more negative counters? I have more positive counters. So my answer is positive 17. So negative 20 minus 3. Okay, so I have negative 20 and I'm trying to take away a positive 3. Well, I don't have positive 3 here. So I'm going to change it to where I'm going to add the opposite. So now my signs are the same. This is like Monday's lesson. My signs are the same, so I can go ahead and combine them and say that I have a total of I have 23 negative counters. Okay, so let's look at this one. Negative 5, and I'm going to add the opposite. So the opposite of negative 8 is positive 8. So now look, I have a negative and a positive. I can't combine these and say that that's 13. They're not the same counter. Okay, they're not the same sign. So I'm going to say 8 minus 5 is 3. Okay, even if the larger numbers last, I can still go ahead and subtract it the way I'm used to subtracting it. So 8 minus 5 is 3. Do I have more positive counters or more negative counters? Well, I have more positive, so my answer is going to be positive 3. So, negative 7 minus 2. Okay, so we have negative 7. Add the opposite. So this is not a negative 2. This is a subtraction of positive 2. So that positive 2 is going to become a negative 2. So negative 7 plus negative 2, since they're the same sign, I get to add and keep the sign. So let's look at it add it with counters. All right, so we're going to have 3 positives, and I'm going to try to take away 8 negatives. Well, I don't have 8 negatives here to take away. So I'm going to creatively add some 0 pairs. So think about what happens when I add a 0 pair, right? What happens when you add 0? Nothing. So we're going to add 0. So that's 3 plus 0 is still 3. Add another 0 pair, plus 0, plus 0, plus 0, plus 0, plus 0, plus 0, plus 0. So now I have 3 plus 0, 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 plus 0. So I still have a value of 3. So now can I take away the 8 negatives? All right, well, let's go ahead and take them away. Okay, they're gone. So now I have these 3 positives plus these 8 negatives left, so that I have an answer of positive 11. All right, so subtracting a negative is just like adding its positive. So on a number line, we're still going to have to change it, okay? We're going to add the opposite. So add the opposite. And now we're going to start at 3, and we're going to add 4 to it. 1, 2, 3, 4. So we end at 7. So our answer is 7. So when subtracting negatives, okay, so when we're subtracting negatives, we added the opposite, okay? So that means we're going to move to the right when we're adding a positive. And when you're subtracting a positive, just like if you were to show a subtraction, you're going to move to the left. All right, so if it was 7 minus 4, you would move this way to get to your 3, okay? All right, let's look at our example, our ones on the back. Which expression below equals 5? So let's work this out. This is a subtraction. Remember, we can't subtract negative 15 from negative 10 because we don't have enough right here. So let's follow our rule. Add the opposite. So our signs are different, so we're going to subtract. And I have more positives than negatives, so my answer is going to be positive. 2 times 3 is 6. My signs are different, so I'm going to subtract, and I have more negatives, so it's negative 7. Here I'm going to add the opposite because it's a subtraction problem. My signs are different, so 4 minus 3 is 1, and it's going to be positive, a positive 1. So which one equals 5? A. All right, number 2. Aurelio has $52 in his checking account. So to me, if he has it, that's a positive 52. He writes a check for $79. That means he pays someone. So that is $79 coming out of his account. That's a negative 79. What is Aurelio's checking account balance after writing the check? So he starts with 52, and then 79 comes out. All right, so he didn't have enough, poor guy. So 79 minus 52, I'm going to find the difference. Since these are different signs, I'm going to find the difference. Okay. So since he spent more than he had, we know that this is going to be a negative 27. So that means he owes the bank $27. So which equation is best represented by the number line below? Okay, so it looks like they start here. So that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. All right, so that looks like they went to 15, and then they subtracted 9 back. So that could be 15 minus 9, or that could be 15 plus a negative 9. Okay, both would start at 15 and move 9 to the left. So it looks like A is our best choice. All right, a little review from last week, which represents 2 times negative 3. So 2 groups of negative 3. Okay, this tells me where to move. I'm going to move left 3 jumps, and then I'm going to do it twice. So I'm going to start at 0. Well, this one moves to the right, so that's going to be just 2 times 3. This, negative 3, that is 2 groups of negative 3. This looks like negative 3 plus 2, because I'm moving to the right 2. And this one's hard to see, but you go to negative 3, and then you go 2 more to the left. Okay, so it could be negative 3 plus negative 2, or you could have negative 3 minus 2. Either way, you're going to get an answer of negative 5 on both of those. So our best answer is going to be G. So on your homework,